So this is part 2 of determining z-scores and using the empirical rule and determining percentiles and various things. So here we go. From the numbers below, we're going to find the area between the mean and the z-score. Okay, so with a normal model, these are z-scores, with 0 being the mean, 1 being a standard deviation, and there's our number. So it wants to know the area, the probability, the percent between 1 and 1 points, between 0, the mean, and 1.17, which is somewhere right about here. So to do that, we go a normal CDF with my lower. Let's go ahead and go to the calculator so I can show you all this. Sorry. So let's clear that. Second distribution, number 2. So my lower is, we're looking from 0 to 1.17. So my lowest number is 0. So 0, 1.17, and these numbers stay the same. Okay, so there's my normal CDF of 0 with a from 0, my lower, to 1.17, which is my upper. There's z-scores of 0 and 1. And so that looks like to be approximately 38%. So that's the area under the curve, 38%. So now we're going from 1.37, negative 1.37, which is somewhere over here. So it's a negative 1.37 between there and the mean and the z-score. So from 0, so from here to here. So we're finding this area. We just found this area. So now we're going the opposite way. So let's second distribution, normal CDF. So instead of this time 0 being my lower number, negative 1.37. Sorry, I put 35. I'm stuck on 5s tonight. 1 point, oh, that is a 5, but that's 1.37. 1.37. Make sure you put a negative in there and not minus. So it's a negative 1.37 to 0, and paste again, and that's about 41%. So Z here, so a normal CDF from a negative 1.37 to 0, with 0 and 1 being my mean and standard deviation, is about, 41%. And if you wanted to make that 42, you're more than welcome to. All right, let's look at the next ones. Now we're given the z-score. Find the percentile rank, percent of individuals scoring below that. So a negative 4.7. So again, my z-score, we're finding the percent. So from our normal CDF, second distribution. Now this time, whoops. Sorry, I didn't mean to do that. Second distribution, number 2 here. So now we're wanting to find, we have a z-score from a negative 0.47, which we're going to say is right about here. A negative 4.7, and we're finding the area shaded this way. So everything below that, that's my z-score. So here we go. So there's my negative 1,000 because I prefer that. A negative, as it just told me, 0.47. Now my z-scores, these are z-scores, so my mean and standard deviation stay the same. And that's the about the 32nd percentile. So I'm going to write 32nd percentile. I put it in normal CDF of a negative 1,000. Negative 1,000 up to negative 0.47 is about the 32nd percentile. And then it asks the same for a z-score of 2.24. So second distribution, number 2. So now I'll just leave that as a negative 1,000, 2.24. This is positive. Now it's a z-score, so my mean and standard deviation stay at 0 and 1. And that's the 99th percentile. Ooh. That's about the 99th percentile. Oops, I didn't mean to write that. 99th percentile. I know I make ugly nines. It's about. That was about. Okay, so numbers below, find the percent of cases falling above the z-score. So in other words, we're switching our things around here. So second distribution, number 2. So instead of negative 1,000 being my minimum, this number is my minimum. So 0.24, I'll go 1,000. That's going to be about 41%. You can put 40.5 if you want to. And then second distribution. So now it's negative 2.07 up to there. And this is going to be a larger percent. It should be much larger, and it is. It's 98%. Okay, here we go. Let's get a new graph going on here. We have a patient that has diagnosed with Alzheimer's, cognitive abilities. The mean is 52. The standard deviation is 5. So that's we're going down below is 47 and 42. All right, so here's what we're looking at. What is the patient's percentile rank? So we're looking at 45, which is about right here. Looking at 45, what is their percentile rank? So we're looking to the left. So this is going to be a negative 1,000 up to this. So a normal CDF. Negative 1,000 up to 45. Now, our numbers now are more are 0 and 1. Our numbers are 52. It's my mean. Standard deviation is 5. And that's, the 8th percentile. Yuck. Did I put that in there right? Second, enter. 45, 52, and 2. Yep. That should be about right, about 8th percentile. Oops, wrong place to write the answer there. 8th percentile. Okay. Okay, so a 5th grader takes a standardized achievement test, mean of 125, standard deviation 15, scores of 148. What's the child's percentile rank? So here we go. I'm going to use this same chart. We're just going to move some numbers around here. Okay, so this is now 148 is my mean. Oh, sorry. 125 is my mean. 15 is that, so that's going to make 140, and this is 155, and this kid's score is a 148. So now we're going from left to right. We're finding the percentile rank. Distribution. I'm going to do something different this time. I'm going to make that 0 because that's the lowest score you can score on these types of problems. So we're going from 0, the smallest number here, which this would be 0, up to 148. My mean is 125. My standard deviation is 15, wasn't it? Yes. And this kid scored about the 94th percentile. Oops. I need to write that down here, 94th percentile. Okay, down here we have, they took a spatial test with a mean of 80 and 8. Pat scored a 76. Chris scored a 94. What percent would score between Pat and Chris? Okay, so here we go. Let me find me another model here. I think I got one. So Pat's, this is going to be 80, 88, 72, And so 76 to 94. So 88, make this a 96. So Pat scored a 76. So Pat's score is going to be right about here. And then, sorry, let me slide the paper up a little bit. And then Chris scored a 94. Good job, Chris. So they're wondering what percent of the graph is between these two. What percent scored in there? So here's my lower, here's my upper. So second distribution, 2, 76 is my lower, my upper is 94. The mean was 80 with a standard deviation of 8. 65% of the group scored between them. So 65% of the individuals scored between Pat and Chris. All right, so we're finding z-scores on number 11. Number 11 says a normal distribution of scores has a standard deviation of 10. Find the z-scores corresponding to each of the values. So a score is 60, where the mean score of the sample data is 40. Okay, score is 60, standard deviation is 10. So that's going to be 60 minus 40 over 10. Looks familiar. 20 over 10 is a z-score of 2. 30 points below the mean. So that's 30. Negative 30 divided by 10 is a negative 3. Okay. A score of 80, because it doesn't tell you the mean there like it did on this one. A score of 80, where the mean score of the data sample is 30. Ah, whoa. So 80, and the standard deviation is still 10. So minus 30 over 10 is 50 over 10, which is a z-score of 5. And nobody scores a z-score of 5. Wow, must be an ugly distribution for someone to get an 80 when the mean of the data is 30. The standard deviation is 10. Okay, so let's finish up this page. We're running out of time. Okay, a z-score of 20 where the mean score is 50. So that's 20 minus 50 over 10, which is a negative 30 out of 10, which is a negative 3. Okay, question 12. As IQ score has a mean of 100, standard deviation 16, Einstein had a z-score of 160. So it says, what's the difference between Einstein's IQ and the mean? So that's 160 minus 100 is 60. So how many standard deviations is that? So that's 60 divided by 16. Clear that out of the way. So 60 divided by 16 is 3.75. Convert Einstein's score to a z-score. Guess what it is? 3.75. There's no converting. No converting whatsoever. If we consider unusual IQ scores to be between -2 and 2, sounds familiar. Is it usual or unusual? And it's unusual because it is 1.75 standard deviations above 2. All right, so we have a women's height with a mean of 63.6 standard deviation. Find the z-score of the height of 70 and determine whether the height is unusual. So 63.6 minus 70 divided by 2.5. You could draw a graph on this, do a quick model, go 63.6, add 2.5 inches, 2 makes 66.1, add 2 to that makes 68.6. So is that unusual? So, but they still ask us to find the z-score, so let's do that. So in parentheses, 63.6 minus 70, close parentheses, divided by 2.5 inches. Yep. It's a negative 2.5. I'm sorry, I did that backwards. That should be 70 minus 63.6. My mistake. Over 2.5. Okay, and that equals 2.56. So yes, it is. And it is unusual. More than 2 standard deviations above the mean. All right. 3 students take a stress test. The highest relative score, which is the highest relative score, meaning it's the largest z-score. All right, so here we go. So we're going to have to do all 3 of these calculations here and make room. So the first one, a score 144, 128, and 34. So 144 minus 128 over 34. The second one here, I'll do them down here. A is 144 minus 128 over 34. B is 90 minus 86 with a standard deviation of 18. And then C is an 18 on a test with a mean of 15. So 18 minus 15 over 5. So the first one is easy. So this is 3 over 5, also known as 0.6. So this ends up being 90 minus 86 divided by 18, which is 4 over 18, which is same as 2/9, which is a 0.2222. And then this one is, I can't do this one in my head, sorry, 144 minus 128 divided by 34. It's a 0.47. So which one had the largest z-score? C did. Okay, ooh, that's ugly looking down there at the bottom of that page. I hope this all made sense to you. Have a great evening.